Thank you, Marianne. Greetings all. Joseph Kursky here at your service. We're going to explore all things mapping our world from global to regional, national, local, and even neighborhood scales. So it's going to be all things mapping. And we're going to talk about some key questions that we've actually started talking about already in the chat. Here's me on a big map of Colorado. I love big maps. I cannot lie. I love all things mapping. If you do not like maps, you're going to be kind of in misery for the next 2 hours, just as a warning. But if you like maps or you think they're useful in society, it's going to be very intriguing. And if you're sort of on the fence about, oh, I'm not sure if maps are all that useful here in our modern digital age, hopefully this workshop, this course will convince you that, yes, that they actually are quite relevant. In fact, I would argue more relevant than ever before as we confront major global issues that increasingly affect our everyday lives that we'll talk about. But here's a big map, a National Geographic map of Colorado. I'm pointing at, my right hand here is pointing where I am right now, which is in the west part of Denver Metro, and it's good to have you all here today. All right, we actually use that big map with kids. We take that big map to schools and lay it out in the gymnasium and in classrooms, and we have some activities that are associated with landforms, ski areas, river systems, population in Colorado. It's just a nice tactile thing to have in schools, have this big map on vinyl. As you can see, I took off my shoes. The only rule really is they have to take off their shoes. This is how to get a hold of me. I work for ESRI, Environmental Systems Research Institute, as a geographer and on their education team. More about that later. But I also teach at the University of Denver, at the University of Minnesota. I'm teaching at Harrisburg Community College right now. They're all online, all the courses that I teach, because my regular job entails quite a bit of travel. And so all the online instruction meshes very well with my schedule. I also work with K-12 educators, so I do a lot of teacher training, professional development for K-12, helping them infuse some of these tools that we're talking about today into their science, social studies, mathematics, economics, and other courses. So I'm happy to chat with you at any time if you've got questions, or, hey, Joseph, I found this really cool map, or something like that, or I want to make my own maps like the ones you showed in the workshop. That's what I'm here for, and I'm just honored to be a part of the community here, and I love working with Marianne and the Academy. So thanks for having me, Marianne. You are awesome and very supportive of all this.
We are honored, Joseph. It's our pleasure.
Well, you're very kind and so wonderful to work with. Here are the things that we're going to grapple with here in our workshop, folks. And we've got a nice small group, so, you know, if you've got questions that come up during the course, feel free to type them in the chat or unmute yourself. You know, I'd like to keep it extremely relevant to your journeying in this mapping pathway. If we had a large group, I usually wait till the end, but we've got a nice small group in here. I think we can do that. First of all, I get this question often as a geographer. Hey, Joseph, haven't all the maps been made? Why are you still in mapping? Haven't we mapped all the terra incognita of the past? Yes, there are still terra incognitas, unknown lands of the present. We'll talk about what those are. People want to map things at finer and finer detail. They want to map additional themes that we've never mapped in the past. I want to map all the invasive species in the wetland down the street from my house, or in a state park, or something like that. Not everything has been mapped in that level of detail. Also, we have new techniques that we can visualize and map things in new ways, for example, in 3D that we never had in the past. So there are new techniques, there are new needs for mapping, and there's also an increased need for real-time mapping real-time information, as we'll talk about here in a moment. In fact, right now, I'm going to go to that right now. So there's a live feed status in something called the Living Atlas of the World, I'm going to put that link in the chat box here, and so you can actually explore what I'm exploring. But the point is, this is just a sample of what people want in mapping nowadays, and that is, I want to map something now or as near real time as possible. So for example, you see the very top one is active hurricanes, cyclones, and typhoons. Quite relevant to the week that we're experiencing here in the USA. So if I open that, I'm going to get this. I'm going to get something called ArcGIS Online, which is the mapping tool that my organization, ESRI, creates for people to be empowered to make decisions based on maps and geographic data. So if I open that live feed, I've got this active hurricanes, typhoons, and cyclones. And you can see here, obviously, no surprise to any of you, we've got the situation going on right now in the East Coast. But we also have this one up at the Southwest Mexico that is on the map because it's getting data from a live feed. And if I scroll around this map, and you of course could do this as well, if I scroll all the way to the Western Pacific, there's also something happening out there. So if I click on these hurricanes and typhoons, I get data. And that's directly related to what we're going to talk about today, that maps are made from something called the Geographic Information System, a GIS, Geographic Information System. The geographic part is the map, the 2D or the 3D map. It could be a satellite image, it could be a topo map, it could be a map of highways. The I part of GIS is the attributes, the information behind the map. So every one of these points, lines, and polygons has intelligence behind them or information behind them. And that's what gives these maps sort of a smart mapping feel to them. They're not just a bunch of, again, features floating out in cyberspace. And they have attributes so that we can understand the characteristics of everything that we're mapping and also the relationships between things. What's the relationship of population now to hurricanes and cyclones? What kind of population density do we have in those areas? For example, if this hurricane is predicted to go onshore at South Carolina, what kind of population is there? What people need to evacuate? What counties need to be alerted, et cetera? So these are planning tools. They're not just for you and I to look at and say, oh gosh, this is horrible, but this is our reality of our modern life. And of course, hurricanes have been happening for centuries and centuries, but now we've got people living in these vulnerable areas. So how do we prepare and mitigate after the fact and rebuild if necessary? Another thing that's powerful about mapping before we get back to our main outline is that you've got, everybody has at their fingertips a variety of different layers in here. So right now, as you can see, all I have is the hurricanes, typhoons, and cyclones layer on top of a base map. The base map right now is a topographic base map, which I can change if I want to. But another thing that we have in here is another live feed, which is current weather and wind station data. So if I expand that, I can say, I want to see those. So I'm just going to click on this little eye. And now I see, oh, well, now I've got a feed coming in from weather stations. So I can see now that, okay, we've got this, it's a hurricane, right? So it's a cyclone and it's a low pressure system, right? So you've got this counterclockwise rotation happening around a cyclone, right? Clockwise in the southern hemisphere, and ditto opposite effects for the high pressure systems, right? Going counterclockwise in the southern hemisphere and clockwise in the northern hemisphere. But fascinating to be able to look at this. So now I can see if I click on any one of these arrows that, okay, I've got some moderate winds happening right now, which is, of course, what you would predict if you looked at this and looked at, okay, there's a hurricane approaching and there's these wind vectors. Okay, what else do I have at my fingertips? If I have this at my fingertips, I can go to the right side of this map and say, you know what, I want to change the style of the map. That's another powerful thing about modern mapping tools. We can change what we're mapping. These aren't just static things. So, okay, I'm going to change that. Instead of wind speed, I'm going to get rid of that wind speed. And now I'm going to say, you know what, I want to add a field. What about the pressure? I know there's pressure in here, so I'm going to search for pressure, and I've got this sea level pressure in millibars. It's not in inches, but same kind of thing. We can change the units if we want to. Okay, so I'm going to add that, and now that I've got this in this mapping the pressure, I'm going to say done, and now I'm going to go ahead and say, gosh, let's go ahead and I'm going to just review that here. So I'm going to ditch the wind speed, and I'm going to say, you know what I really want is the pressure. So I'm going to search on pressure here, and pressure in millibars, add that. So now my prediction is that, okay, if it's a hurricane, the default is in this horrible, they're too large, right? The symbols are way too large. So I'm going to go to style options. I'm going to say, you know what, I don't want these symbols to be from 9 to 100. I want them to be a little bit less than that so I can actually see. The lower the pressure, the smaller the orange orangish dot, but I still don't really see the variation there. So instead of high to low, and instead of this kind of symbol, what I'd rather have is color instead of a size, because pressure, right, there's a fairly low range, right? You've got 950, let's say, in millibars here to 1,050. So it's only a range of 100 in millibars. And as you know, in inches of mercury, it's usually 29.7, right, to 30.2-ish. It's not that much of a difference, but it's enough where you've got these big hurricanes and other systems rolling over the landscape. It's enough to change them a little bit, but because it's such a small variation, I think color might be a better way to map this. So let's go ahead and say color. And now I'm getting closer to what I really wanted. And that is, I've got a whiter, sort of a tannish colored dot for the lower pressure. And then I've got a purplish for a higher pressure. So I'm liking that fairly well, but let's go to style options and say, I really don't like this purple to tan. I'm going to change the color ramp to something else. So, look at these choices I've got at my fingertips. I can say, what about something like this, where I've got a very different kind of a purplish in high and a yellowish in low. And I'm going to say done there. And now I've got this. Okay, looks good. The only other change I want to make now is the base map. The base map still makes this a little bit cluttered. So now I'm going to go to the left side and say base map. I don't want the topographic base map now. I want something like, how about terrain with labels? So I don't have a tinted appearance on the base map. I'm going to say terrain with labels. I'm done tinkering with the base map now. And okay, now I've got a pretty good idea of what's going on here. What do I have here? I've got the hurricane, and I've got all these low pressure stations reporting low pressure right now, or maybe 15 minutes ago. Let's just take a look at this at 9:53. So this is about 20 minutes ago. You can see that the temperature, et cetera, but you can also see some other information in here. Fascinating to be able to do this. Okay, interesting. So I've got some low pressure here. Wouldn't it be great to have a legend on here? So remember, I've got several different layers in this map, but the low pressure are the yellowish colored weather stations. And that makes sense, right? Because a hurricane is a low pressure system. So all these low pressures around the hurricane. Okay, well, that's interesting. But of course, this zone of precipitation that's around the hurricane, as you can see here, we've got a hurricane, we've got the track coming in here and so on, this cone of forecast, hurricane warning, obviously here, the force is part of the legend. But I also have one more thing that I wanted to show, and that is, what about, let's add another layer in here, and let's say I want to browse layers and add these to this map. I'm going to add the GOES weather. This is the geospatial observation Earth system satellite operated from NOAA. Okay, I want that colorized satellite imagery. Let's see what we've got there. Because what I'm getting at is, oh gosh, look at this. What I'm getting at is that I've got additional layers that maybe would help me understand the situation a little bit better. I've got that. I've got this infrared satellite imagery here. Let's go ahead and take a look at that. That's good. So I'm going to go ahead and exit this. And now I'm going to go back to my map layers, and I'm going to go to where I was before, and I'm going to zoom in there. And now I'm going to see that, okay, based on, I've got basically the idea that I'm getting at is, I like that, but it's covering up everything else, right? Look, I've got some properties in here. Look, one of them is transparency. And look, as I grab this transparency tool, it's making that satellite image, which is overlaying on the top. Some of you may be remembering this. Remember in the old, not too distant past, a lot of instructors taught with a transparency projector, right? It was a bunch of plasticky sort of mylar layers that you'd put on a transparency, and then you'd shine that into the front of the room. That was before the days of computer projectors. That's kind of like what we're talking about here. All these layers are like transparencies. They're translucent. And so I can adjust the translucency of each one of these, because what I was getting at is not just this little cone that we had on that one layer. It's the cloud cover from the hurricane, as you can see, is vast. It covers thousands and thousands of square miles, right? So now I've got a better sense of, wow, that is a major weather system, isn't it? And I can adjust these transparencies around as I please. That way it helps me to understand what the situation is. And that really is the essence of modern mapping in 5 minutes. So let's recap. I've got real-time data feeds, different layers, and the relevance of mapping is, okay, I'm taking this example. Guess what? When I planned this course, I hadn't intended to show that example, but it's an example of, okay, we've got a relevant something happening in the news, and mapping is a key part of understanding and mitigating and rescuing and preparing and so on. So that is just a little bit of a taste of what we're going to explore. And hopefully that was of interest to you all, because it shows within about a few minutes, probably less if I hadn't been talking so much, you, me, others can actually start understanding what's the situation with natural hazards, water, urban sprawl, energy, and a bunch of other issues on our 21st century world. Questions, comments so far? Hey, Leslie.
Hi, Joseph. So this is a website that's available to everybody.
Yeah, notice in the top right, I'm not signed in.
Oh, okay.
And so that live feed status, if you start there, that's where I started.
Awesome.
And I also wanted to put in this is the presentation that I started with. I'm going to put that in the chat so you can explore further on the things that I've got there. So yeah, but very good question. Exactly. I'm not signed into anything. This is using something called ArcGIS Online. Think of it as sort of a Google Maps plus intelligence. I mean, Google Maps has intelligence in it too, because you can find your way from your house to the coffee shop, or your way across campus, or your way to your kid's house, or whatever, right?
Right.
But this is even more intelligent than that, because this is a real geographic information system that's online, running in a browser. And these services for NOAA and the typhoon data and the weather feeds, they're all on different servers. And it's kind of like, oh gosh, when you have a fitness app, maybe some of you have a fitness app that you're recording all your walks, your runs, your cycle rides, and that data is stored on some server somewhere. The map data, you don't really care where it is, as long as it works and as long as you can figure out that, oh, okay, I've gone 2.5 miles today instead of 2 miles. Yeah, that type of thing.
Yeah.
The same thing with this. These are stored on different servers, but agencies like NOAA, NASA, USGS, my organization, and others, State of Colorado Department of Natural Resources, they make this data available. And in the past, it was all available on media. So DVDs, CD-ROMs, and then, as the 90s kind of came to a close, okay, let's start putting this stuff online so people can access it without physical media, because that's kind of clunky and I have to load it on and it's not real time. And so as this whole evolution of mapping progressed, now we have something called data as services linked to data sets. And the nice advantage, of course, one of the many advantages is that they're scalable, right? We can zoom in and out. And also that many of them, not every one of them, but many of them are actually real-time or near real-time, especially critical in a situation like this. We don't really care about last week's weather so much, right? We want to know what's going on right now. Okay, so, and of course, as the day goes on today, these feeds will change, right? The weather stations will change, the position of the hurricane will change, and so on. And you can see that if we journey down, no, this is great, Leslie. As we journey down this pathway, we could add things like, ooh, give me the population density living along the coast in South Carolina, or inland and the Piedmont in North Carolina, et cetera. Highways for evacuation routes, et cetera. So that hopefully was at least one of the partial answers anyway to this, haven't all the maps been made? No, because people want real time and they want detailed information that we could never map in the past. Then secondly, we'll delve more in the next coming moments, but also in the next session. Are paper maps still relevant? This is a big question as well. One of the things that I wanted to share, though, my own answer as a geographer in this, and someone who loves, like I think most of you, because you live in Colorado and you love getting outside onto our beautiful landscapes. This is Mesa County behind me. This is Grand Junction. The Book Cliffs, the far hills in the distance there are Utah. Yeah, way over there. That's Utah in the distance. So that's where I grew up. And I love Mesa County. I love the buttes, the mountains, the mesas, the canyons. I love the eastern slope as well. But my main heart is still with the western slope, even though I'm living on the eastern slope now. But I do love all Colorado landscapes, even the Great Plains. There's a lot of beauty out there as well. Different kind of beauty, right? But there's beauty everywhere. Anyway, the point is, when you go hiking, it's important to read the landscape signs to where north is, where the drainages are running, and to have a backup copy of where you are, i.e. a paper map that maybe is laminated, like from National Geographic maps. Trails Illustrated people up in Evergreen, they make those nice laminated topo maps that are weather resistant, so if it rains, it's okay, that type of thing. Because for one reason, your device can and will fail, right? Your electronic device will fail. Your GPS unit, your cell phone won't have signal, and sometimes it's a matter of, as you know, your own personal safety, that you actually have a backup copy of whatever map that you've got. Very important. So paper maps are still relevant for that reason. Going out into the wilderness, right? We all see articles every year about people that have wandered around, and they're wandering for hours or days, and they have exposure to the elements, and it can be life-threatening, right? So it's important to be able to interpret the landscape, but also understand how to read a paper map associated with directional indications, where the sun is hitting. If it's cloudy, how can I read the signs on the landscape itself? Again, that's one of many reasons why I think paper maps are still relevant. Probably a lot of you have paper maps in your house. I know I have a lot. I used to work at U.S. Geological Survey, for example, so I've got lots of topographic maps and thematic maps, and I'm going to talk about some of my favorite maps and give you an opportunity to talk about some of your favorite maps in this class. That'll be fun. But paper maps are still relevant. They are also limited. You can't change the scale. They can be damaged. You can have a flood in your house, and they are static in scale. They're static in time. They're an imprint of when that map was printed. They also don't allow us to do this kind of thing that we just did with the hurricanes. You can't change the scale and add data to them and make them change the symbology. You're stuck with whoever created that map. And indeed, that leads into another discussion here today, and that is everyone now is a potential map maker. It's not just the USGSs and the Ordnance Surveys of the UK, the British Topographic Survey, the United Nations Environment Program, State of Colorado Department of Transportation. In the past, those were the map makers, science and data agencies. Now, everyone has the capability of making these maps in a dynamic way. And that has huge implications for data quality, the number of maps that are online, the fact that there are lots of good maps and authoritative maps, but also maps that you kind of question, did they have the right data? Is it at the right scale? Is it the right map projection? All those sorts of things that we'll chat about. So there's some data quality issues for sure, but as the volume of maps grows, the number of good maps grows, but the number of maps that are really very difficult to understand also grows. So we'll talk about the implications of that. But I think that paper maps are still relevant. Paper maps nowadays are actually derived from the digital data, as you probably would expect. In the early days of digital mapping and geographic information systems, what we were trying to do with GIS is replicate what we did with paper. So we actually took the paper, scanned the data, or digitized the data on big digitizing tablets that looked like big drafting tables, basically, with a light underneath and a sensor network of a mesh that you could determine what the position is on the landscape based on that mesh. But all of the paper data was converted into digital form, and that's how the digital maps came into being. Nowadays, it's kind of gone full circle. The paper maps are actually generated from geographic information systems. If people want a paper map, like if you go to usgs.gov and go to the store, .usgs.gov, or to Trails Illustrated, National Geographic up in Evergreen, or any other map dealer, they may have a shelf set of paper maps, but oftentimes they're actually generating it on the fly based on your needs. I want this area of the country or this area of the world, and I want it at this scale, and please print me that custom map. I have mixed feelings about that. I still love those days. We can kind of go into map stores and browse around. Some of you may remember Mapsco at, I think it was about 8th and Broadway in Denver. That was the last major big map store in Denver, and that's closed. There was one in Boulder, and that closed. And the USGS map store where I used to work in that building at the Federal Center in Lakewood, that's closed. Why? Because there's a smaller number of people that actually want those paper maps, and they're usually customized. So there's not enough volume to keep those stores open, sadly. I think just a little twinge there. But I understand it because, again, people they want to be able to do what we just did about 10 minutes ago. And then third, how can maps solve our 21st century challenges? We've got a lot of challenges in our world, right? From hazards to equity to population change, biodiversity loss, habitat loss, natural hazards, as we just explored, sustainable fisheries, sustainable agriculture. You look at the UN Sustainable Development Goals, all of those, human health, etc. I think, by the way, at my organization, we've had a health team for many years. And I think before 2020, people wondered, why does a geographic information systems company have a health team? But I think when COVID happened and all those dashboards appeared, we'll talk about the JHU COVID dashboard and others, and just infographics on COVID and how it spread and how do we need to have a mask mandate, et cetera, et cetera. I don't think most people wonder what the connection is between geography, mapping, and health anymore. There still may be a few, but before that, we did get a lot of questions. Now there's not so many. Sadly, it took a crisis for people to realize, gosh, that this is really relevant to health issues. It's not just COVID, right? But variables, lifestyle variables, what's the incidences of certain diseases around the planet or even in my own state for certain, is there any relationship between behaviors to health variables, et cetera. So health is a very much of an intertwined geography, GIS topic. So maps can help us to understand our world and to solve our 21st century challenges. We have a very complex planet, don't we? It's not the same, it's not a sphere, as you know, for one thing. It's wider around the equator than it is around the poles. It's an oblate spheroid, It's not a perfect sphere. And as some of you were chatting with me about before the session began today, we'll chat a little bit about the history of how we came to understand our world through mapping. But one of the interesting stories in that past was there was a French surveying team that sent in the 1730s a group to Svalbard up north of Norway and another group down to Ecuador to figure out if the Earth was a oblate spheroid, like it truly is, or whether it was a prolate spheroid, like an egg shape. An egg would be very much exaggerated, but something along those lines, whether it was a prolate or a oblate spheroid. They knew it wasn't a perfect sphere by that time. But how do we do that? We're going to measure 1 degree of latitude in the northern latitudes, and we're going to measure 1 degree of latitude at the equator and see how much they're different. Ooh, interesting. So that is an interesting story right there. These old surveyors were extremely, as surveyors are nowadays as well, extremely dedicated and wanting to do of the most accurate job possible. And you can imagine back then, there was no GPS or no global positioning systems, no digital mapping systems. They were all using chains, actual physical chains they would have to drag with them. And these chains would stretch a little bit as they were used. So they weren't completely accurate, but they also had to set up elevations in trees and other high places so they could triangulate, have it a person on a high point, and then I'm going to triangulate and measure the next point what I can see, and I'm going to measure the difference in elevation and also the difference in the angle from true north. So as they would set up these stations, often it was very arduous, and they would be building ladders, and then there were all kinds of things that this French surveying team didn't encounter in France, in Norway, and also in Ecuador. Snakes, pythons, other things. And the natives, of course, were wondering, well, what are these foreigners doing in our country? So there was a lot of diplomacy and arguing back and forth. And so, but it's amazing how accurate those people were. And the French surveying team actually did discover that, oh, darn, that English guy was right after all. Newton was right. It is an oblate spheroid. It is wider around the equator than around the poles. Anyway, the point is, these folks are very dedicated, past and present, in mapping, and it's helping to understand our world. We don't just all of a sudden have all these tools at our fingertips because Google Maps came around in 2005. it's actually centuries of progress in mapping that we'll dip a little toe into here during the workshop that hopefully is pretty intriguing. But summing up on that story about the French surveying team, map makers, cartographers, people mapping their community, their city, and global issues and phenomenon have always been very dedicated and striving to be as accurate as possible. Maps can help us solve our 21st century challenges, I truly believe. We have to have the geographic perspective and the holistic perspective too about, the lithosphere, the rocks, the soil is connected to the biosphere, is connected to the atmosphere, is connected to the anthroposphere, the human sphere. 7.5 billion of us modifying the planet in various ways. It is connected to the hydrosphere, is connected to the cryosphere, the ice sphere, and so on. So they're all connected. And so by altering something in one sphere, we're changing what's happening in another. So that holistic view is important, and mapping helps us get there.